Hello, this is Miss Moore, and today during chemistry we're going to discuss oxidation and reduction. Today's essential question: how are oxidation numbers assigned? Redox reactions. Reduction-oxidation reactions, also known as redox reactions, involve the transfer of electrons. So reduction is the loss of oxygen or the gain of electrons. Oxidation is the gain of oxygen or the loss of electrons. Okay, let's try to do just a really quick basic example of a redox reaction. Okay, so the first thing I'm going to do is I'm going to draw the Lewis dot structure for these two atoms we have here, magnesium and sulfur. Magnesium has 2 valence electrons and sulfur has 6. Magnesium's a metal, sulfur is a nonmetal, so when they get into the vicinity of each other, they're probably going to hook up with an ionic bond. So the way that's going to work is magnesium is going to lose 2 electrons, right? So magnesium loses 2 electrons, and what actually happens is that he gives his electrons to sulfur. So what's just happened to magnesium? Magnesium has just been oxidized because magnesium just lost a couple of electrons. Sulfur has been reduced because sulfur just gained 2 electrons. So, I'm going to have a mess going on here in a minute. Magnesium from the reactant side to the product side has been oxidized, while sulfur from the reactant side to the product side has just been reduced. Okay? Truthfully, when we write this equation, we wouldn't put in, at this point, the Mg2 plus and the S2 minus. So let's get rid of some of this stuff and write what the equation would really look like. So we would have Mg plus S produces MgS, right? Because this 2 plus and 2 minus are going to hook up. However, we're still going to have magnesium to go from the reactant side to the product side had to have lost a couple of electrons to become a 2 plus. So magnesium has been oxidized, and sulfur is going to gain 2 electrons to become a 2 minus. So sulfur has just been reduced. Okay, so that's the real basic idea of a redox. We're going to spend a lot more time on this. All right, next up is oxidation numbers. And we need to understand oxidation numbers so that in future we can go into more detail on redox reactions. So an oxidation number is a positive or negative number assigned to an atom to indicate its degree of oxidation or reduction. When assigning oxidation numbers, the sign, meaning the positive or negative, is written before the number. Okay, so for example, Mg, if we were writing it as an ion, we'd be talking about it being 2 plus. Okay, but its oxidation number, so this would be its charge. That's how we've been writing charges. But if we were going to be talking about its oxidation number, we would write it as Mg plus 2. All right, rules for assigning oxidation numbers. You need to know these rules to be able to assign oxidation numbers, and you need to be able to assign oxidation numbers to be able to do redox reactions. Okay, so we'll go through the list of rules, and then we'll try some sample problems, which will hopefully help. So free elements are always 0. And a free element is just an element hanging out by itself. So if you saw Mg or O2 or whatever, their oxidation number would be 0. For ions and ionic compounds, the oxidation number is the same as the charge of the ion. So for example, we'll use the example we were just working on. If we had MgS, the oxidation number for Mg is, better change colors here, +2. The oxidation number for S is -2. Because Mg has a 2+ charge, S has a 2- charge in this ionic compound. The oxidation number for oxygen is always -2. And hydrogen is +1 when it's bonded with nonmetals. And if you remember, when hydrogen is bonded with nonmetals, it's written first. And it's -1 when hydrogen is bonded with metals. Okay, in neutral compounds, the sum of all the oxidation numbers is 0. All right, this sounds a little strange, but as we go through it, hopefully you'll find it's not really too bad. All right, practice with oxidation numbers. Let's try this out. All right, so we have H2O. So we have H's and we have O's. There's no free elements here. So let's go back and look at our rules real quick. H is +1 when it's bonded with a nonmetal and -1 when it's bonded with a metal. Looking at this one right here. Well, H is bonded with O, which is a nonmetal, which means that our H is bonded with a nonmetal. So that means his oxidation number is +1. Now let's look at oxygen. Oxygen is always 2-. 2-. All right, let's look back at this last rule here, number 5. In neutral compounds, the sum of the oxidation number is always 0. So now what we need to do, this +1 here is for each H. But how many H's do we have? We have H2, which means we have 2 H's. Each H is +1, which means our overall oxidation number for our H's is +2, and our O is -2. So we did this correctly. That comes up to equal 0. Okay, let's try calcium chloride, or CaCl2. Let's look at our rules and see what could apply here. Those are not free elements, but this is an ionic compound, and so the oxidation number is going to be the same as the charge of the ion. So chlorine, the charge on a chlorine is 1-, right? So that means our oxidation number is -1 for a chlorine. And calcium is +2 because calcium has a 2+ charge. To make sure we did this right, we have 1 calcium, so we have a total of a +2 for the calcium oxidation. And chlorine, we have 2 of them, which means we have -1 and -1. You add those all up, it comes up to 0. All right, the next one is slightly more tricky. So we have NaSO3. This also follows the rule for ions and ionic compounds. It's a charge of the ion, partially, because we have Na and we have SO3. The problem is for oxidation numbers, we actually have to give an oxidation number for each and every atom. But we do know that Na has a 1+ charge, which means its oxidation number is +1. We also know about the O's, right? All O's have an oxidation number of 2-. So we'll put a 2- here. Now we're going to use this last rule to figure out the oxidation number on sulfur. We're going to use the rule in neutral compounds, the sum of the oxidation number is always 0. So for the NAs, we know we have a +1. We don't know about the S yet. We know that the O's are 2-, however, there are 3 of them. Whoops, I didn't do a very good job on that. Let me try that again, make that a little bit more clear. We have 2-, 2-, 2-. So we have a total of -6, and we have a total of 1+, which means the sulfur's oxidation number has to be +5. so that it adds up to being neutral. So we'll put that as plus 5. Okay, for the next one, K2CR2O7, why don't you hit pause, see if you can do this by yourself, and then hit play and see how you did. All right, this particular compound is an ionic compound. It's potassium dichromate with, we've got K, which is potassium, and then Cr2O7. We can use the rule that for ions and ionic compounds, it is the charge of the ion for the potassium. So for potassium, we know that it has a 1 plus charge, so the oxidation number is plus 1. We also know that all oxygens are 2 minus. There's no rule for chromium, so we're going to have to figure out chromium. All right, so we have 2 potassium, so we have plus 1, and we have 7 oxygens, 1, 2, 3, 4, 5, 6, 7. So right now we have a total of 2 pluses and 2, 4, 6, 8, 10, 12, 14. We have 14 minuses. Well, to make this neutral or to make it 0, the chromium altogether needs to be what? Plus 12. However, there are 2 chromiums, so each chromium needs to be plus 6. Okay, for the last one, MgH2PO4 I'd again like you to hit pause and see how you do, and then hit play. But I want to remind you that since we have this parentheses 2, when we're figuring out the total number of positives and negatives, that 2 distributes. So MgH2PO4 is another ionic compound. It's magnesium dihydrogen phosphate. So we have magnesium, which is a cation, and dihydrogen phosphate, a polyatomic, which is the anion. So we can once again use the charge of magnesium as the oxidation number for magnesium. So it's going to be plus 2. From our rules, we know that oxygen is going to be 2 minus, and we know that hydrogen is going to be 1 plus. So now we just need to figure out what in the world is phosphorus. So we have how many magnesiums? We have 1 magnesium. Hydrogens, we have 2 times 2, right? So we have 4 hydrogens. So we have 1, 2, 3, 4 hydrogens. And oxygens, we have 2 times 4, which is 8. So we have 8 oxygens. 1, 2, 3, 4, 5, 6, 7, 8. All right, so what's our total negative? We have 2, 4, 6, 8, 10, 12, 14, 16. We have a negative 16. And our positives, we have 2, 3, 4, 5, 6. So what does our phosphate need to be? Well, to get the charge to get the oxidation numbers to be neutral or add up to 0, we need to have a minus 10. How many phosphorus do we have? Well, 2 times 1 is 2, so we have 2 phosphorus, which means each one needs to be negative 5. A quick review of oxidation and reduction. And during our discussion, we'll talk about the reaction, magnesium plus oxygen producing magnesium oxide. All right, oxidation. The definition of oxidation is the losing of electrons or the gaining of oxygen. Let's just start with that. When we're trying to find oxidation or what was oxidized, we're going to look at what's on the reactant side and compare that to what has happened on the product side. So looking at magnesium, magnesium is a lone atom on the reactant side, but on the product side, he is hooked up with oxygen in an ionic bond, which means magnesium on the product side is Mg2+, right? He's lost 2 electrons. Lost electrons. That means that magnesium was oxidized. Looking at the second definition of oxidation, oxidation is an increase in oxidation number. So make a little room here. If you remember the rules for assigning oxidation numbers, free atoms have an oxidation number of 0, which means magnesium has an oxidation number of 0. When we look at magnesium on the product side, it's an ion and ionic bond, so the oxidation number is its charge, right? So the oxidation number of magnesium here is 2+, a +2, which is indeed an increase in oxidation number. Okay, next up, reduction. So reduction is the gaining of electrons or the losing of oxygen. So let's go to our example and let's look at oxygen. Oxygen on the reactant side is a free atom. On the product side, however, oxygen is hooked up with magnesium in an ionic bond. We know his charge is 2-, meaning that he gained 2 electrons, which gaining electrons reduction. That means oxygen was reduced. Right, and if we look at definition B of reduction, make a little room here. Reduction is a decrease in oxidation number. So if we go back to look at our reaction, on the reactant side, oxygen is a free atom, right? Which means, again, his oxidation number is 0. When we go to the product side, however, oxygen is in an ionic bond with magnesium, which means that the oxidation number is the same as the charge. So the oxidation number on oxygen is -2. That is a decrease in oxidation number. Okay, so there's a quick review of oxidation and reduction. All right, next we need to talk about oxidizing agents and reducing agents. This can get a little bit more confusing, but if you get through, it's not that big of a deal. So really quickly, let's put our labels back in. If you remember, magnesium was oxidized because magnesium lost 2 electrons, right? Magnesium lost 2 electrons. Here's the deal. Where did those electrons actually go? Didn't they go to oxygen here? Oxygen was reduced because it gained electrons, in this case 2 electrons. Where did it gain the electrons from? Well, from magnesium. So an oxidizing agent is the thing that causes the oxidation of the other substance by accepting electrons, which means that the oxidizing agent in this case is oxygen. Oxygen is the oxidizing agent. Because of oxygen, because of oxygen, magnesium lost 2 electrons. Okay, the reverse is also true. The reducing agent. The reducing agent causes the reduction of another substances by providing electrons. So how in the world did oxygen get reduced, or how did oxygen gain electrons? Well, because he got them from magnesium. So magnesium is the, that wasn't a very good line, magnesium is the reducing agent. That's really all there is to it. Okay, let's practice assigning who's been oxidized, who's been reduced, who's the oxidizing agent, and who's reducing agent. And let's do that by assigning oxidation numbers. Okay, so with number 1, copper is a free atom, which means he's got an oxidation number of 0. And then we have silver nitrate. We know that silver nitrate is an ionic compound, and we know nitrogen as a whole has a 1- charge, which means silver as a whole has to have a 1+ charge, which means the oxidation number of silver is +1. Okay, so to assign the oxidation number of oxygen, we know that it has to have a -2 each oxygen, right? And there are 3 of them, so it's -2, -2, -2. And then we have +1 for silver. So we have 2, 4, 6 minuses and 1 plus, which means our nitrogen must have an oxidation number of +5. All right, let's go to the other side. Using the same rules again, we start with silver because that's the easiest. Free element, oxidation of number of 0. We know again that oxygen is -2. Copper now, looking at the same thing, nitrate as a whole has a -1, which means copper must be +1, which means its oxidation number must be +1. And using the same logic as we did with silver nitrate, we know that nitrogen has an oxidation number of +5. Okay, so now that we have all these oxidation numbers, how do we figure who has been oxidized and who's been reduced? Well, remember that an increase in oxidation number is oxidation, and reduction is a decrease in oxidation number. So if we remember that, we'll know who has been oxidized and who has been reduced. So let's look. Copper went from 0 to +1. Well, I would say that copper was oxidized because his oxidation number was increased. Okay, silver went from +1 to 0. So guess who was reduced? That is correct. That would be silver. And it looks like nitrogen went from +5 to +5, no change, and oxygen went from -2 to -2, no change. So now we know who's been oxidized and who's been reduced. So now, who is the oxidizing agent? When copper lost his 2 electrons, where did they go? Or lost his 1 electron, sorry, where did they go? They went to the silver. This silver nitrate is the oxidizing agent. You don't just say the silver is the oxidizing agent, you use the whole compound. So silver nitrate is the oxidizing agent. Okay, well, while copper was being oxidized, silver was being reduced, meaning silver gained an electron. Where did that electron come from? It came from copper, which means that copper is our reducing agent. Okay, this might sound really bad. It's really not. Let's try another one. Hopefully you'll feel a little bit better. All right, let's start again by assigning oxidation numbers. We know that hydrogens are always +1, and there are 2 of them, which means our sulfur must be -2. Okay, again, we've got hydrogen, which is going to be a +1. Our oxygens are, I wrote that backwards, +1. Our oxygens are going to be -2. However, there are 3 of them, so we have -2, -2, -2, which is 6. And we only have a +1. Remember, this whole thing needs to be neutral, which means our nitrogen must be +5. On the other side, we have sulfur, which is a lone atom, so he's going to be a 0. We have oxygen, which is -2, and it's connected to a nitrogen, and this compound needs to be neutral, so that means, I shouldn't say neutral, the sum of the oxidation numbers needs to equal 0, which means the nitrogen must be +2. All right, then we've got water. Hydrogen is +1, oxygen is -2, and the sum of those equals 0 because we have 2 hydrogens. Okay, let's figure out who has been oxidized, keeping in mind that somebody that's been oxidized has an increase in oxidation number. So we have hydrogen, which has a +1 on the reactant side and on the product side. Our sulfur went from -2 to 0, which is an increase in oxidation number. That means that sulfur has been oxidized. So who has been reduced? Well, let's keep looking. Our hydrogen didn't change. Our nitrogen went from a +5 to a +2. He has a decrease in oxidation number. So nitrogen here has been reduced. All right, so now who's the oxidizing reagent? Who is the reducing reagent? Well, sulfur from the reactant side to the product side has been has been oxidized, meaning sulfur lost some electrons. Where did those electrons go? Who took them? The nitrogen. So our reducing agent, our oxidizing agent is going to be HNO3. And nitrogen was reduced from the reactant side to the product side, meaning nitrogen gained electrons. Where did nitrogen get those electrons? Well, from the sulfur in the H2S, of course. So our reducing agent is going to be H2S. Okay, now I realize this seems sort of complicated. It really, really isn't. A little bit of practice, you're going to be fine. All right, that's it for today.